title of the presentation is really beyond concrete. So we are talking about materials which usually require less amount of carbon intensity, have less amount of carbon intensity, are technologies that actually reduce the amount of concrete that they use. And when I'm talking generally, I'm not just talking about concrete, but also other materials which are high embodied energy, and I'll go through that. So this research is, of course, part of, well, a couple of years, and there has been 3 publications on this journey, and all of them are readily available. You can download them. Global and Indian context, the construction sector contributes about 34% of global energy-related CO2 emissions. About 500 tons of CO2 annually from embodied carbon is what comes out. Concrete is the world's second most used material after water. It uses large quantities of sand, gravel, water, which do not replenish easily. And cement production is, of course, very, very highly energy intensive. In fact, if cement industry was a country, it would rank among the 3 or 4 global CO2 emitters, the top 3 or 4 global CO2 emitters. And this, of course, means that we need material choices and buildings design that will strongly influence India's ability to meet its climate commitments. In fact, India Cooling Action Plan sets a goal of achieving thermal comfort for all, which means that we need better kind of materials that we are using. And of course, we also have the net zero carbon emission by 2070, which also means we have to take care of the embodied energy of the material, how it's produced. So, both how it's produced as well as how it's actually behaving in terms of giving you thermal comfort or energy efficiency. So, in basically the building material choices we make today will be central in shaping the carbon intensity of future building stock. Now, what we did a research, and what we found out was that majorly it was out of the 4 major construction technologies that were being used in terms of walling, it was monolithic concrete which was actually dominating along with AAC. So AAC and monolithic concrete both were started to dominate mass housing projects in, let's say, Delhi NCR, or in this case, we also did it in Bengaluru, Tumkuru. So major cities are transitioning towards that. Now, this is scary because majorly, and we also did a small study in which we did a heat ingress analysis. On what we found out was that if we took the same house and we compared it to different materials that existed in the market, monolithic concrete was probably behaving, I mean, it was coming out to be almost twice, it was allowing about twice as much heat as compared to other materials such as, let's say, compressed earthen bricks, unstabilized adobe bricks, stabilized adobe bricks, stabilized ram dirt. So all of these materials are behaving much better than what monolithic concrete bricks were behaving. So this is a general idea of how the U value or heat transmittance actually is behaving in terms of these 3 walls. On your left, you have the monolithic concrete wall. Even a normal 9-inch red brick wall is actually behaving, has a lesser heat transmission value by 30%. And an AC wall of the same size as a concrete wall would usually have, let's say, 60 to 70% less heat transmission value. So you can understand that if you're using concrete as a material on your walling, then it's becoming a really big problem in terms of your energy efficiency and thermal comfort. And sadly, this is now a selling point for developers. They usually write that RCC wall construction quality, but it also reflects the fact that most users who are buying the homes are not aware that this is actually a bad thing for them. So I'm going to cut to the chase, and I'm going to talk about various walling technologies as well as other technologies which reduce their dependency on concrete. So walling technologies, we of course have something like even a rat trap bond, or a terracotta block, which reduce the dependence on the amount of material in itself that you're using. And of course, in traditional construction, you would have many technologies such as the cart kuni, the masonry, random rubble masonry, the dhaji devari, and all those materials, those technologies are very much prevalent in areas where stone and wood are available, or in some places when stone are available. But there are other technologies which are much more widely available all throughout the country. So many earth-based construction technologies such as, let's say, rammed earth, wattle and daub, compressed earthen blocks, cob wall, adobe blocks, they're all very much prevalent in all other parts of the country. In fact, what you see on the left of your screen is rammed earth, which was very prominently has been used in areas such as Spiti as well as Ladakh. Now, those regions have the kind of soil that can take these kind of that you can use for these kind of construction. You also have something like a cob wall, which essentially uses earth as a material, and it's perhaps one of the oldest technologies in the world when humans started making their dwellings. And compressed earthen block that you see on the right is a modern version, a variation of some of these technologies combined, in which we add a little bit of cement. But overall, compressed earthen brick also has that advantage that once you're making these blocks, you can make them in a way that you don't need mortar to put one block over the other. They can also be made in a way that they're interlocking, self-interlocking in themselves, and that reduces your dependency on mortar itself, as well as the labor that would be required for this. And these technologies actually have been used in modern buildings as well. For example, this is a case in Bangalore, which I believe used about 1.5 crore of these blocks to build their housing society. So, even modern construction with large scale modern construction has started to adopt these technologies for their being. And yeah, our publication sort of also gives a step by step guide if you want to download them. But apart from the wallings, I believe the roofs and floors are the ones where we are not able to think beyond normal concrete, because walls you can think about many other technologies, but roofs and floors is really a challenge. So yes, there are technologies in which, let's say, something like a filler slab, in which you use concrete but you reduce the amount of concrete that you use, and that is because you're placing some sort of a material which occupies volume but does not it does not occupy, it takes away the concrete from areas where there is no requirement of concrete itself. And there are another interesting version of this that you would see in this image, in which one of the innovators has actually done, what they've done is they've used recycled plastic balls inside their slab. So what it does is it reduces the amount of concrete, this much amount of concrete. And what it also does is that you don't actually need this concrete. So the structural stability remains the same. But eventually, what also happens is that your entire weight that is coming onto the columns, which might also be made of concrete, reduces, because you're reducing the weight of the wall itself, the weight of the slab itself. There are other technologies such as precast, brick panel, and joist system, in which you have concrete beams running, but then the gaps between the concrete beams are not filled with concrete, but is filled by the with a precast brick panel that is made on ground and then placed above. You also have something like a ferrocement roofing channels. In essence, ferrocement is concrete, but it uses a lot less amount of material. The panels themselves are much more thinner, and the steel is much less than what you would be using in traditional way of covering your house. You also have something like jack arches, where you can actually design it in a way that you have small, imagine them to be small vaults, in which all the members in between are in compression. And therefore, you don't actually need concrete to span one, let's say, one of these between these members, and it can all be done by, let's say, bricks, or even by compressed earthen bricks or certain materials like that. Then we also have shallow domes. Now, I think this is one of those technologies which I wish a lot more people knew about and used, because it's wonderful. You can actually, a shallow dome, if you make your house out of shallow dome, you all of the members are in compression, and therefore you don't need any amount of steel to span your roof. And you can make it out of compressed earthen brick. You can also make it out of normal brick. And what it does is it reduces the amount of concrete significantly. You can see that there is no steel that is actually required to make such a site of a shallow dome. It's also called as a Rothak dome in normal language. And you can see that it's a very shallow sort of a shell which is made. And in fact, it's actually can be even faster in construction as compared to RCC, because an RCC slab will take some time to cure and then get its strength. This can be used a few days after it's constructed. So you can see how the masons would be doing it. They start with the edge. And another interesting point about this is that it can span square shapes, rectangle shapes, as well as circular shapes. So it's been used in all of those forms as well. Uh, and and then a lot of you would also be aware that this is a way of spanning an area, so you don't require concrete if you're able to have that, if you have the luxury of this space to be able to span it with a slight curve. So this is a dome, and it's completely made with compressed earthen brick. So no, not even normal red bricks which are higher in embodied energy and which actually require a lot of energy to just be made. None of those were used. And some of these images just prove that once it was made, people can stand above it and there is no problem with it. And I'm just showing you a few images just to show you some of these technologies have been used in modern construction. So this is one hotel in West Bengal which completely just uses Adobe blocks. And above, if you look at above, some of those areas just uses elephant grass and some sort of a terracotta tile. And in some areas, you would see that they have not used concrete to span their buildings. In some areas, they have. So wherever they had toilets, they had used concrete for that area. Now, even in those areas, they had used filler slabs to be able to do it. This is again an image of a building which completely used, none of the members were made of concrete. It just used Adobe blocks and wood. If you just have a look at the interiors as well. Now, this is a hotel now. Even the interiors are made without any concrete. So many of these technologies exist. Now, this is another building in West Bengal. This uses a technology called wattle and daub, and above that, there is a thatch roof. And also modern technology has been used to be able to make these walls. And once we think of these walls, we think, oh, how will you put how would the services go, how would the electrical wirings go? But all of those things are also now possible, and that's been innovated into these things. And of course, something as what we think about as thatch roof, which we think of, oh, it's in a rural area, but beautiful buildings have started now coming up with, innovative people have started building thatch roofs into it as well. I'm also going to talk about a technology which is concrete but not quite. So this is what we call a poured earth concrete, in which we have used, what they have done is, instead of sand, they've used earth. So you don't have to bring sand from far away. And these buildings that you see are made from poured earth concrete. In the central area, they've used jack arches. So even that concrete they have used. Of course, there is some amount of concrete that is visible. So they have used some amount of concrete, but a lot of it is also poured earth concrete, which is better. But this is a technology which is still under development. Any other elements? So, for example, this is a beam and a column which is made partially with concrete but partially without it. So these are columns which are made with compressed earthen bricks. In the center, you have, let's say, steel bars, and because of which you can use them. And the compression is taken by the compressed earthen blocks. Majorly, this is a precast beam. So usually we imagine beams as something that you cast on site, but this is a precast beam. It uses compressed earthen blocks. And all of these technologies are available. They have been tested with load, and these are ready to go. And some of these projects that I'm showing you do not use much concrete. They're all which reduce their dependency on concrete. So I'll end with this slide. This is a movie. This is a image from a movie called Humans in the Loop, and it's about how people in Chhattisgarh are training in tribal areas. I don't remember where, are training AI, and labeling things so that the AI software can sort of understand. So this woman who has a moral dilemma because she does not want to um, does not want to tag this particular insect as a pest. But those are one of the options she has been given. It's not a crop, it's not an agricultural equipment, it's not a pesticide. But she only has an option of tagging it as a pest. But she knows that actually this particular insect is actually good for the plant and its the plant itself. So she has this moral dilemma, and I think this is where we also need to work upon. We need to play around with the labels and perceptions we are giving them. So next time you're looking at these technologies, maybe what your mind might say is vernacular, traditional, mud house, alternative, rural technologies, or perhaps the worst of them all, which is like a kacha house. So perhaps those labels and perceptions need to change. And with that, I'll say thank you.